transform, all are 1. We move ahead with another example. xt is xt is e power minus 80 ut plus e power 80 u of minus t, e power minus a of mod t. It is combination of previously done question, these two questions. We directly use Fourier transform of these two. 1 upon a plus j omega plus 1 upon a minus j omega are the Fourier transform of these two. By taking Fourier transform in both direction, we directly got the Fourier transform of these two. By addition of these two, we got the result 2a square plus omega square plus a square plus omega square. For magnitude spectra and phase spectra, we separate the we discuss Fourier transform of x omega equals to 2a upon a square plus omega square. Now we segregate the magnitude spectra and phase spectra. Magnitude spectra is 2a upon a square plus omega square, and phase spectra for this is 0. Magnitude spectra is even function of omega, and phase spectra is odd function of omega because signal is real. Minus a mod t. This combination is represented as e power a mod t. We can represent e power ut plus u of minus t. We can draw its magnitude spectra by putting value omega equals to 0, 2 by a. Omega equals to 0, a cancel with a, and 2 by a. 2 by a. At omega equals to infinite, minus infinite. If we minus these two terms, xt e power minus 80 u of t minus 80 u of minus t. Now Fourier transform of this combination is j omega minus j omega. Result will be minus j omega into 2 upon a square omega square x omega, and signal may be look like as 1 minus 1 t. If we put xt limit a tends to 0, limit a tends to 0, e power minus 80 ut minus e power 80 u of minus t. By putting limit a tends to 0, this expression is reduced to this way, and this graphical represented now converted into this way. This is known as signum function. This all complete work in time domain. This limit also applied in frequency domain also. Limit limit a tends to 0, limit a tends to 0, minus 2a omega 2j omega a square omega square. By putting a equals to 0, I got 2 upon j omega. We have another transform, Fourier transform pair is signum function is 2 upon j omega. We can also draw the spectrum of signum function by putting the value. As we put the value 0, there is value infinite blast. Just increase the value and means it is following this pattern positively and negatively. Omega scale is decreased by 1 upon 2j. Magnitude spectra can be look like as, and phase spectra is minus 90 degree. For positive frequency, for negative frequency plus 90 degree. Signum function, phase spectra and magnitude spectra may be represented in this way. Move further with very important signal rectangular pulse, which is very important in communication and signal also. What is rectangular pulse? I denote xt equals to a rect t upon capital T. Mathematically, rectangular pulse denoted as a for the range of t by 2 to minus t by 2 to plus t by 2, otherwise 0. We can rewrite in this way mathematically. Mod of t, otherwise 0. We want to calculate the Fourier transform of this. Just put in the formula and we get the Fourier transform. For Fourier transform, formula is minus infinite to finite xt e power j omega t minus dt. By putting value into the formula, minus t by 2 to t by 2 a e power j omega t dt. A is constant, remaining term integrated. 2a 0 to t by 2 e power j omega t dt. First integrate 2a to t upon minus j omega t by 2. Now we put the values. A 2a upon j omega minus e minus j omega t by 2 minus 1. Rearrange with this value. We take out some common by some formula. 2 a e power j, we rewrite this equation in this way, minus j omega t by 2 minus e power j omega t by 2, 2 is not common, minus j omega a e power j omega t by 2 minus omega t by 2 upon omega. We use 2 before and 2 here, so it completely term of the sine omega t. So this expression is reduced to 2a upon omega sine omega t by 2. This expression is completely reduced to 2a upon omega sine omega t by 2. Rectangular function Fourier transform is at sine omega t by 2 upon omega. A sine 2a sine omega t by 2. Actually, rectangular function is graphically denoted by minus t by 2 to t by 2 a. 2a sine omega t by 2 upon omega. We can convert sine function into another format which is called as sin function cx, sine theta upon theta. There are two formats to represent this, sine pi x upon pi x. No difference between these two ideas. Difference is only angle. Here angle is in radian. Here angle in radian per pi. That is the only difference. Otherwise both ideas are same. So we want to make rectangular in term of sin function a 2 sine omega t by 2 upon omega. We need this 2 here. We need extra t. Now this term is completely revised, sine at sine omega t by 2 upon omega t by 2. At this juncture we can convert it into sin function sine c omega t by 2. At sine c omega t by 2. It is sin function. Sin function is represented in this idea, sine theta upon theta, sine pi x upon pi x. This is the basic idea for sin function. Sin function used for filtering and interpolation, and we can represent in this way. Little bit discussion on sin function. What is sin function? Very useful function. It is mostly used. How can important property of sin? Sin cx is an even function of x. Second one is sin cx is 0 for x equals to plus minus n pi, where n equals to 1, 2, 3, 4, 5 and so on. Third, using L hospital rule, sin C is 0, sin C 0 equals to 1. Maximum value can be calculated with the help of L hospital rule. Sin C 0 is 1. Sinc function is basically product of sin Cx is basically product of product of an oscillator signal, oscillatory signal, periodic signal sin x, a oscillatory periodic signal sin x, where t equals to 2 pi, and monotonously decreasing function 1 upon x. Therefore, sinc function is periodic of period. Sinc function is periodic of period 2 pi, and its amplitude is governed by 1 upon x. I am drawing sinc function, sinc Cx. I am drawing this function in this way. Sinc function may be drawn in this way. Amplitude is governed by 1 upon x. 1 upon x is monotonous decreasing function. And repetition is governed by sine function 2 pi. This is called as sinc function. Sinc function, very important function for bandwidth calculation in communication, and very important for the point of view exam. In exam, sinc